Alright, hi everyone, welcome to my YouTube channel City of Electrons, and in this video we'll be talking about simple plots, how to make simple plots in MATLAB. So of course you can check out the previous videos in this playlist, and then so you get to follow up, okay, like follow up well. Okay, now what we want to do now is simple plots here in MATLAB. So the thing is this: to make a, when we say simple plot, we just mean like normal graph, okay, graph of, have x, you have x and y, just something like that. Okay, that's what we're talking about. So the thing is, in MATLAB, these are x and y. We are going to have values here now. We are going to have values here, okay, 1, 2, 3 and so on. Also we are going to have values here. Okay, so MATLAB, to make a plot, we require vector. And when we say vector in this case, we just mean a one-dimensional array. Okay, array of one dimension. So x vector will just mean that there will be values for x and there will also be values for y. Okay, then in saying that, for us to make a successful plot, the number of values for x, that is the elements in the array x, should be equal to the element in the array y. So if we have 3 elements here, we should also have 3 elements here. Okay, so let's go to MATLAB and quickly do this. Alright, so let's define x. Let's define x. Let's give it some numbers. Let's say 1, 2, and put a comma there. Now if you don't put comma, it will still work, okay? If you don't put comma, it will still work, but I just like to put commas for, I just like to put them. Now our colon will of course save the value of x here. Now look at this. This is the name of the variable x. This is the value. That's the set of 1, 2, 3 and like that. Now this is the size. This is a 1/6. Okay, 1/6 matrix. That means we have 1 row and 6 columns. That means 1 row, this is what we have here, and then 6 columns. So 1, 2, 3, 4, 5, 6. Okay, and the the class is double. So now let's give values to y. Then I will show you something later. Let's give values to y. Let's say y has element 3, it has -1, it has 2, it has 4, 5, and then 1. Yep. So check this out. Let's see what happens here. Now we also have, now these are the values in the variable y, and the size is also 1/6. Since they are of the same size, we can work with them. Okay, so now to plot a graph is super easy in MATLAB. Just say plots and then you put your variables there, x, y. You set. Okay, now if I put the semicolon, it means MATLAB will not give me the results. But when I don't have a semicolon there, just press enter, MATLAB will give me the results. Okay, so let's just, yeah, that's it, perfect. Okay, so what is going on here is that we have the x, values of x, look at them, 1, 1, 2, 2. So when x is 1, y is 3. When x is 1, y is what? 3. When x is 2, y is -1. When x is 2, y is -1. When x is 3, y is 2. When x is 3, y is 2. If you even go close, you will see the thing. I like to add something to it to make it easy to see, and it's just to type grid on. When you type grid on and press enter, you will see the lines. This makes it easy for you to just like point out to say when x is 3, y is 2. When x is 3, y is 2. Sure, you see how they match now. So now it's clear. Okay, so let's go back to this. I should close that now. I want to see more of the command window. Alright, now Now there's one important thing to note here. Like we said, for us to make this plot, they have to be of the same size. Imagine that one of them is maybe more than the other. That means we cannot match it with these other values, but this we can match it because they are the same, 1 by 6, 1 by 6. So we can match each value to each element to the other. Okay, so now with that being said, there is something else we can do with this. Instead of defining, like saying these are the y values, then these are the x values, we can just say let x be this, and then we write an equation for y. Something like saying this is the x values. So we can now say y should be y equals sine x. Okay, y equals sine x. Okay, still maintain the same 1 by 6. So that means when x, we have changed the value of y now. Okay, so it means when x is 1, y will be sine x. When x is 2, y will be sine 2. Okay, when x is 1, y will be sine 1. When x is 2, y will be sine 2. Just like that. So let's make the plot of this and see what happens. Plot x comma y. Okay, all right, so we have a different shape now. Grid on. You can just click this. Instead of going to type grid on, you can just simply click this and you have your grid there. Okay, yeah, so when x is 1, we have y as sine 1. Note that this sign is in radian, not in degrees. If we want the sign in degrees, we have to do this. We have to say y equals sine d. Sine d means sign in degrees. Sine d, then we'll put x. Okay, now let's plot again and see if, of course it cannot be the same. It can't be the same because the values will be different. So let's plot again. Yeah, so clearly it's different. So yeah, so we've gotten some, like, a lot of tricks in this video, okay, which is to add grid to it. Okay, the plots, with this you can plot the graph, and with this you can add grid to it, and with this we've seen that this is sine in radian, but if you want it in degrees, you just put d, sine in degrees. The same applies to cos, tan, and the rest of it like that. Okay, then one other thing, let's clear the screen and do something else, okay, which will help us in terms of working with range. So let's clear the screen. CLC clears the screen. Oh, I think I should clear my workspace also. So clear. Okay, CLC is to clear command, like command window, clear everything there. Now let's see if we want to find the plot a graph over a given range. So let's say x starts from 0 to 2 times pi. Okay, now what this means is that this column here, it means x takes values from 0 to 2 times pi. That's the meaning. Okay, but how do we increase? Like, what's the increment here? The increment here is by 1. So the first value will be 0, second value will be 1, second value will be 2, until we get to 2 times pi. Or let me just use something, just a number for now. Let's say 6. Okay, so x will have values from 0, 1, 2, 3, 4, 5, 6, then it will stop. But if we do something else by saying 0.5, then put colon. If we do this, it means x will have values from 0 to 6, but it will be changing, or it will increase by 0.5. So the first value will be 0, second value will be 0.5, next value will be 1, next value will be 1.5, and so on. So with this we can now say let y be let's use cos this time, and want it in degrees, cos d of x. Okay, cos d of x. So now let's plot x comma y. Okay, yeah, funny. So we see it's changing by 0.1, 0.1. And one interesting thing is that if the change is very small, your curve will look smooth compared to if your change is very large. So you can try that out. Okay, I think we've done a lot of examples here. You can try that out, okay, and see what happens. So let me just try an example I have here which is this 0 change by pi divided by 100, and then 2 times pi. Okay, 2 times pi. All right, then y equals sine, of course this is in radians already, sine that. So up, yeah. Like what I'm doing now is I'm using the arrow keys in my keyboard to, when I press up, that's arrow keys pointing upward, I can go to previous commands and then select. Alright, nice. So of course I can turn on the grid. Okay, so this will be all for this video. Okay, so in this video we learned about basic plots, just to plot graph, and the fact that the vectors should be of the same size. Look at them, it's working well, same size, so they are all working fine. Okay, and then we learned how to use this command and then adding grid to it, either by clicking this or you just press grid on and you have that. And the fact that when you add d to either cos, tan, sine, it makes it in degrees. But if you don't add d, if you just write it like that, cos or sine, it is in radian. Okay, so I hope this is helpful, and in next video we'll talk about how to beautify our graph, like add things to it and make it look nice. Okay, so thanks for watching, and I'll see you in the next video. Bye for now.